Hey everybody, I'm Uttam, and today we're going to talk about a bit of Elixir. So so this is about me, the customary information, in case you want to get in touch. And yeah, I currently work with Equal Experts. I've been professionally programming for 12 years now, I think. So I'm older than I look, hopefully. All right. And that's me. Yeah. So, what is functional programming anyway, right? I mean, I tried to think about this, and you go on the internet, you get different answers. So it looks like everybody has a different, opinion of what functional programming is. This is kind of my definition, by no means the canonical definition of functional programming. For me, the most important aspect of functional programming is that it's declarative, which basically means you describe what things are rather than how to do stuff. You say, the other declarative language which everybody knows is HTML, right? You define that this is what my page looks like. You don't define, exactly how the DOM should insert nodes into your page, right? And you could have divs, anywhere, but they could be, styled to, some can come on the top and some can come on the bottom, right? So it's declarative. It's not in any order. It doesn't tell you, do this and then do that. It tells you this is how something looks, right? So that's declarative for me, right? But most of us are used to writing imperative code. If you've come from a traditional Java, C#, C++, whatever, right? We're used to, telling instructions to the computer, do this, then do that, right? So that's different in functional programming. The other key aspect is the concept of immutable state, which means you don't change variables, you don't assign, right? You do expressions instead of statements, right? So you don't say change this value to this. You define a new variable or an object or a structure, right? Which is like a rule in functional programming. You can't go beyond that, right? And also the concept of data being separate from functions. So if you come from the object-oriented world, it's you model your real world objects as objects in your code, and you kind of bind the functions to the code, and they live together, they're coupled, right? But in the case of functional programming, they're decoupled. A function takes in an input and gives an output. The only coupling is at this level, what you call into a function and what it returns, and nothing more, nothing less, right? So that's one part. Also, I think functions are first-class citizens, which means functions can be passed to another function and they can be returned from a function. Right? And this is true even in a lot of the old school Java, C#, because these things have come in. You have lambdas, etc. Right? In Java 8, you've got lambdas, and C# had lambdas probably 10 years ago, right? So this is quite familiar, I guess, but not so much. This feature isn't as used in the object-oriented world as it is in the functional world. Right. The other thing which you'll find different in functional programming is you don't have imperative for loops with for I equal to 0 where you change a variable, etc. They are done using recursion or using methods like map, which internally use recursion technically, right? So this is something which will be different for people coming from a traditional, object-oriented programming background. So that's my kind of definition of functional programming, right? So moving on. Why is functional programming important, right? So functional programming is not something new which came up recently. It was invented in the 50s. Maybe Lisp was invented in 1958, and garbage collection existed in the 60s. It's not very new. But then the hardware was really, it didn't have the capacity to match, because functional programming took more from the hardware than what an imperative program does. Because in imperative programs, you could manage memory, you could micromanage memory, you could deallocate memory. So when your memory size, your machines were smaller, it made sense to have more control, right? That's where C++, etc. came in, right? And then Java came in the 90s and said, hey, you know what, don't worry about memory management, we'll do the memory management for you, because machines became faster, right? And your processor clock speeds were getting faster and faster, and that's where Java became such a big force to reckon with, right? I remember when I started my career, people were like, hey, it's written in C++ because Java isn't performant enough. But now you see databases written in Java, right? I mean, it's amazing. However, this is stopped. Processor clock speed have started getting slower now. Not slower, sorry, my bad. Haven't been improving. The way they've said is you need, I'll give you more cores on your machine rather than making processors faster, which basically means that you have to, your programs have to be done in parallel, right? And all of us know how hard it is to write programs with threads in Java, for example. Right? It's not fun. It feels you have to manage locks, you have to do multiple things, right? So it's you get more bugs because of that and lots of issues, right? However, if you see functional programming, since state is immutable, the programmer doesn't have to worry about this. The underlying runtime can take care of parallelizing because since state is immutable, you don't need locks and you could do a lot of things with that. And I think that's why functional programming is more relevant in today's day, right, than it was ever before, right? Unless there are some hardware improvements where clock speeds start going up and nobody really cares again, right? But that's not happening right now, right? You could also argue that code is easier to read. Obviously, once you get used to the syntax, because all of us are used to the algol-based C, Java kind of syntaxes. But there are functional languages which make it easier also. It's not like everybody uses Lisp. There are different kinds of functional languages, right? And if you have good type inference and type checking, it's easier to enforce correctness at compile time rather than doing it at runtime. You don't get null pointers, etc. Right, and I think this is what functional programming is, and I think this is like the next wave. Probably in the 80s, you had object-oriented programming coming in, and everybody was like, "We're happy with COBOL or whatever." But now, it's object-oriented programming. Guys are saying, "Hey, you know what? We can do just fine with my regular object-oriented code." But it's good to think about the future as developers, right? Awesome. But like I said, a lot of us are used to traditional languages because most of the business programs in the world are written in Java, C#, and they're written 10 years ago, 15 years ago, and you still have to maintain them. They do make a lot of money for you, and we're like, hey, you know what, it works for me. Why should I, just build functional languages, right? So this is like a good XKCD about Haskell, where everybody, it's kind of self-explanatory there. However, I think we still do a bit of functional programming, right? I mean, I wouldn't say functional programming. There are a lot of concepts that have been borrowed over into the object-oriented world. The first one being, immutable objects, right? Strings were immutable objects. When I started object-oriented programming, I couldn't make sense because everywhere else you say, hey, you know what, you can change the state, but the string class says, no, I have a string constant pool, and you just have to make it immutable, right? And we've known this, right? I mean, it's been there, right? We've not been using it as much, but we know. Also, I think as the object-oriented program design improved, things like not having setters or not changing state became good programming practice, right? You would never do setters. I mean, for example, I program in Java for a living every day, even now. And one thing which we never ever do is have setters on our objects, right? They're always constructed freshly, which is immutability in the end. So these concepts have been borrowed, right? Also preferring composition over inheritance. Composition is also a functional programming concept. Lambdas, of course, I mean, everybody familiar with lambdas here in Java and C#, right? So map, reduce, all those things, and even link in C#, right? They come from, the functional programming world. Java has also gone one step ahead by having things like optionals built into the language, which is also an example of a functional programming concept, which is a dreaded M word, which I'm not going to mention. All right. However, these features are just like a bolt-on to the existing language. So people who are comfortable with, the old school, it's easy to go back to a for loop, and I've done that. I confess. Right? Sometimes then you can't get things going quickly. You just like, let me just write a for loop with an I and j, and let me just finish this off. Right? So you have that temptation to go back to the imperative way of doing things, unless the language forces you not to, right? So it's nicer to, learn a paradigm in a language that is designed for it rather than, not designed for it. Right? Of course, there are hybrid languages like Scala which support multiple paradigms, but again, I still feel you have the temptation to go back to your old habits. So I would ideally want to learn something, in a language which helps me learn functional programming rather than, just helps me unlearn object orientation, right? So I started with Haskell initially, and it was fun initially, but then I found it to be a little more academic. But this is my opinion. I couldn't build real world stuff with it. I'm a guy who likes to hack stuff, build stuff, and just doing algorithms was a little boring for me, right? So then I kind of chose Elixir, right? And it was amazing compared to the other languages that I tried. Even I tried Clojure for some time, right? So what is Elixir, right? It is a dynamic and functional language, so it's dynamic. It runs on the Erlang VM. So everybody heard of the Erlang language in VM here? So Erlang was built in the 80s at Ericsson. So they built it for telecom systems, right? It was like an internal language, and platform called OTP, or Open Telecom Platform, right? For running, programs, right? So they kind of open sourced that in the 90s. However, the language was based on Prolog, which wasn't similar to what we used to, like Algol style languages like C. So it never took off. People would just look at it and say, hey, what, this doesn't look nice. So let me not learn this stuff, right? But in a lot of people still used it. A very niche segment still used it in telecom systems and highly distributed systems, right? Then there's this guy called Jose Valen. So he's the core committer in Ruby on Rails, or Ruby, not quite remember what. So he was trying to get Ruby to get better at concurrency, and he gave up and he said, okay, let me try Erlang, and he was impressed by the concurrency features of Erlang, right? But he also probably loved the developer happiness that the Ruby programming language gave you, right? So he said, let me create a new language with a syntax that is inspired by Ruby. So that's where Elixir came into being. Right? And it's fully kind of compatible with Erlang. So it's like how Scala is to Java. You can call Java library from Scala. You can call Erlang functions from within Elixir. So they're like that, right? So that was awesome. So the syntax is inspired from Ruby. It's got a very developer-friendly tooling and ecosystem, which you will see in the demo that I will give. Right? So that's Elixir. Cool. Okay, let's show some code. I think talked enough. So Elixir ships with this build tool called Mix, right? So, what's this? Right, so if you want to start a new module or a library, you just say Mix new. So let's start a new library called FizzBuzz. Everybody familiar with FizzBuzz here? Awesome, right? Jeff Atwood, okay. All right, so it's as simple as that. You say Mix new FizzBuzz. As you see, it's created the entire project structure for you, right? Including the test. Right, so let's go to the code. So if you see, there's a FizzBuzz test here, right? It's generated, right? So it's there, and you can just run it now, right? It's a hello world. You don't have to write a hello world. You can just run it. Oops, you have to cd into the directory, obviously, and it's running, right? Cool. So let's test drive a simple FizzBuzz with Elixir, right? The test class is, sorry, not class, too much Java, right? The test module has been generated for you, and let's change this function to, everybody understands FizzBuzz, right? But let me just talk about what it is. It's just a function which takes in a number, and if it's divisible by 3, it prints fizz. If it's divisible by 5, it prints buzz. If it's divisible by both 3 and 5, it prints FizzBuzz. And if it's not divisible by both 3 and 5, it prints the number back, right? So let's start with that, right? So let's start the first test. Return fizz if divisible by 3, right? So instead of hello, let's call it run, unless you guys have a better name for the function. Couldn't come up with one. Let's say what's divisible by 3? 9. Right, and let's say it prints fizz, right? So this is your assertion. So let's run the test. it says run is undefined. So let's create the function. Right, so I'll take the auto-generated documentation for clarity's sake. So let's change the hello function to run, which takes in a variable called x. And as good TDD practitioners, we'll just do what is required to run the test. Right? You'll notice there's no return statement. If you're familiar with Groovy, you'll be familiar with this, right? So let's run our test here. All right? There you go. It runs. So let's go to the next scenario now, right? So what's the next scenario? We need it to be divisible by 5. It should print buzz, right? So 5 print buzz. So let's take what, 10 is divisible by 5, and then we'll say buzz. Let's run our tests. Failure, expected buzz, but was fizz, obviously. Let's go back here. So how do? You'd want a condition here, right? If divisible by 3, right? So there's one way in Elixir, it's called cond. You just do this, and you just say remainder of. If you see, it gives you dividend comma, it's like an if condition. So what's it's x, and divisor is 3, right? Equal to 0. Then return fizz. And else, which is just true, return pass. Let's run this test. Cool, works. Now let's talk about the next scenario, which is both divisible by 3 and 5, right? So let's write a test for that. So should return fizz buzz and 15. Sorry, by both 3 and 5. 15 is the number, right? So instead of 15, let's choose 30, right? It should be fizz buzz, right? And it's fizz because we've not implemented it. So let's write another thing here. Let's say for 5, it should be buzz, right? Else fizz buzz. All right. Is this fine? All right, fine. Oh, still fizz. Oops. Sorry, which one? Yeah, good point. Yeah, so we should probably make this 15, right? And make this, so basically it goes from top to bottom. Thanks for that. And 5 will be buzz, else will be fizz. Fine. Fine. Cool. Sorry? Have I? Okay. So what's the final test? The final test is if it's not divisible by either 3 and 5, you should return the number back. Return number if not divisible by both 3 and 5. Yeah. So let's choose a number like 7, right? Obviously, we've not written the code for it, so let's write the code for it. So 15, 5, so we'll do this as x instead, so that we'll have the default condition as x, and we will do this. Yeah, there you go. So this is one way of writing code. However, you could make it much better in Elixir. So let's just see how we can do this. All right. So Elixir has this feature called guard clauses, which is kind of related to pattern matching, but it's not, and I'll show you how. Okay? So let's comment out this method for now, and let's write a different way of doing this in Elixir, right? So when I think of this function, what do I think? Like I said, declarative, right? When I think of this function, I think def run of x, okay, when rem of x comma 15 is equal to 0, right? then you can say do fizzbuzz, right? Similarly, when run of x, when this is 5, you can say buzz, and when run of x by 3, you can say fizz, right? And the default case is take the when out, and you can just say do, right, x, right? So this is like the, how you do in maths, right? You write f of x when this is this. This is very similar to that, and this is the way you think in functional programming, where you have different function definitions. You don't find this in regular languages. You can do function overloading in Java, for example, but you cannot do this, right? And this makes your program clear, because when you just go and you know what's happening here. It's as simple as that. So let's run our test for this. It's the same, right? So this is the first hello world program here, right? I would never do const. When I program in Elixir, I'll never do conditions. I'll always do this, because that's the nicer way of doing things in Elixir. You can avoid if conditions in Elixir by just having these functions. You don't need ifs, right? Cool. So let's move on. So now we also said everything stateless, right? If I didn't mention in Elixir, you can't change state. You can't change a value of a variable. Whatever comes in a function, you can return something new, right? So how do you manage state in a stateless world, right? I mean, so there are multiple ways of doing it, and one way which Elixir does is by passing messages. So in Elixir, you have this concept called as a process. Okay, if you're familiar with the Scala concept of actors, they are like standalone processes. They are not OS processes. They are just, virtual processes inside the Elixir VM, right? And you can have millions of these talking to each other, right? So the way you manage state is a process can manage state in a certain way. You'll see how. We'll write a program for that. And then you just keep passing messages, telling it to do something or ask something from the process. And it's kind of decoupled, right? So let's do that. So let's create a new project for that, right? So let's say mix new, let's call a simple process a counter, which just maintains it gives you a way to increment a number, and it gives you like state when you ask for it, right? It's like a simple state, right? So I've created the counter project. Let's go to the counter test again, right? Obviously this is generated. So the first test, what will the first test? So let's say we initialize the counter with a value, right? So let's write that test. So initial value, let's say instead of counter.world, we'll say counter.init. Let's say you init it with 5, it doesn't matter, whichever value you init, right? And this gives you a process ID. So this is something which is unique, you wouldn't find in a regular programming language. When you spawn a process or initialize something, it gives you a PID, right? That's how you can use to, reference that process and get the value of state, right? So this will give you a PID, and then you can have a function called value, which will take in the PID and return you the value of that, right? So let's do that. So run the test, cd counter, mix test. Obviously counter.init is undefined, so let's start with that, right? I'm going to take this out here, and let's have an init, okay? Okay, so there are multiple abstractions in Elixir. It's not Elixir technically, it's called the OTP. It's the Open Telecom Platform, not just for telecom these days, but the name is stuck. So all the whole process message passing infrastructure is given to you by OTP, right? So OTP has concept of processes. It has abstractions like agents and gen servers. So what I'm going to show today is the gen server. A gen server just means general server, right? I mean, not HTTP or anything. It just serves something. Given a message, it serves you something. So let's actually write a simple gen server module for a counter, right? So let's call it counter.genServer or counter.server rather, right? And let's actually have a function called start link or start, right? And this usually takes in your initial value, right? So what you do is you just say counter server.start here. All right, and you pass it the initial value. However, what this returns is a tuple, which is, this is another error handling pattern you'll see. Whenever you do something weird or something stateful, it returns you whether the operation succeeded and the actual return value, right? Which is the PID in this case, right? So this returns you this, and I'm going to return the PID from here, right? And let's see how we can implement the start link. We can say genServer. You also have to say use genServer, which is a macro. It injects some specific code into it. It's kind of like inheritance, but it's not. So at runtime, it injects some functions into this, so you don't have to write it yourself, right? So that's what a use means in Elixir, right? So we'll say genServer.startLink again. Sorry. And the current module is referenced by this, right? And you just give it your arguments, which is what initial value. Okay, so this is what this returns, right? So now let's run a test and see what fails now. Okay, now the first thing is passed, init has passed. There were 2 lines here. Now value is failing. We have to implement, how to get a value here, right? So let's do that. So let's add a value function here, which takes a PID because you want to know which process you're asking for. You can't just, it's not a global, right? So it takes in a process ID and then, gives you the value, right? So then what you could do is you could do a genServer dot call, right? It takes in a PID. That's what the server means. It takes in a request. A request is generally a tuple of what operation you're requesting for, right? It gives you this, and just take the timeout, not required. It's totally optional, right? And it just gives you this value, right? It just says genServer get me, it's passing a message called value, and it's expecting something to be returned from that, right? From that process. That's what call means. So let's just run this test. Awesome, that's an error because genServer attempted to call something, but there is no handle call method, which means we have to implement that function in our counter server. So let's just do that, all right? So it's called handle call. Okay, I'll use the autocomplete abilities of this, all right? And you give whatever request you want to give, which is, in this case, this is pattern matching, by the way. You can just say when handle call is called with this value, okay, and let's ignore from for now, and some state, then do something and return something, right? In this case, we just have to return like a reply. You return a reply. Again, this is message passing. You got in a message called value, you're returning back a message with a reply and a return value if you want. There are 3 arguments here because you have to also return the new state. Let's say this handle call was modifying the state. You also have to return back the new state, and that's how state is managed. We'll come to that a little in the next test. Let's make this pass first. Awesome. So our test passes, right? Now let's implement the cream of functionality for the counter, right? It's called increment, surprisingly, right? Increment. We'll do an init again. Oops. PID is equal to counter dot init. Let's say 10 this time, anything, right? And then you'll say, oops, let's say counter dot increment, right, of PID. Let's say this returns a value, or you could not choose to return a value. In this case, let's say it returns a value, right? And increment takes a PID and by how much you want to increment. Let's say 2, right? and you can say assert counter.increment is what? 12. All right. So let's run the test again. Obviously increment is undefined, so let's just go and define this. All right. So def increment again takes in a PID comma amount. Sorry. And it's a gen server call again. Okay, we'll say the PID, and the request is increment. Again, it's a tuple. It's a message. It's always a tuple, and you'll say amount. We'll pass another thing to the tuple. Don't need the timeout. Let's run the test again. Same error. There's no matching clause. So now this is where the beauty of pattern matching comes in, right? So I can, if it was something like Java, I would have a function called handle call, and I would have if conditions in it. If messages this, do this. But because Elixir has pattern matching, I can just say handle call increment amount. People who use ES6 in JavaScript will be familiar with destructuring. It's kind of like that, but it's way more powerful than this destructuring in JavaScript, right? Now you need to calculate a new state, right? So you have to say new state is equal to state plus amount, all right? And instead of returning just the state, we also return the new state as the third argument. This also has to be new state again, right? Need not be, but in our case it has to be, right? So you return a reply, what you want to return, and the new state of your server back, right? Something like a reducer in Redux, if you guys are familiar with the JavaScript library also, right? So that's it. So this is like a gen server now, right? There's a lot of things to read here, right? It feels like it's like you have to say get a PID, do this, and then pass the PID on to the next thing. So you can make this more readable in Elixir. Let's see how we can do that, right? So Elixir has this concept of a pipeline operator. This is like how you use Unix pipes. So which means it passes the output of one into the input of the other, right? So you can just say value equal to init, and you can just say count, and you don't need to pass the, you can just say counter.value. You don't need to keep passing the PID around anymore, right? Right? So this becomes your, oops, what did I do? I forgot the equal to. Formatter died on me. All right. Right. So this is another way of writing this, right? This is way more readable. You don't, you just come, you're initting a counter with 5 and you're just getting the value. You don't have to worry there is a PID, blah, blah, blah. It just works. All right. Let's run the test. No, so we could do the same thing even here, or we could just say, counter dot increment to counter dot increment, and we can just say value equal to, and there you go. Oops. What did I do wrong? Damn it. 2. Awesome. So what we saw here is we saw how to manage state in Elixir, and how pattern matching works. So you can have multiple handle calls like this, and they're different functions. They're not the same functions, right? Fortunately, you don't have to do this a lot. Let's say when you're doing web development, everything's stateless. You get a request, you transform it to something, you probably save it using a library which already has state implemented. So on a regular day, you wouldn't do this. But let's say you're building like a caching layer yourself where you want state or something. It's important to know what, how you manage state in Elixir. All right, cool. Let's move on. Okay, this is another question which, there are religious debates. It's like this tabs versus spaces debate, right? Static or dynamic, right? I think it's a bit of both. So since it's inspired by Ruby, and even Erlang is dynamic by default, so it's dynamic by default, as you saw, right? We didn't have any types. But you can it uses type inference. It has a compiler, right? It's not like how JavaScript was or how even Java was originally, right? Where it's interpreted and you could do anything. In JavaScript, you can write globals and you could do anything. No, this compiles to the Erlang VM, which is called Beam. So like a class file, you have Beam files, right? It's very similar. So it does compile. So there is a compile phase, and it will fail. So for example, if I just write some random stuff here, my program isn't going to run. The compiler is going to kill me first, right? It's the compilation error. It's not a runtime error, right? So there is a compiler. However, it's very forgiving by default, and it tries to infer your types, as much as possible. However, if you think your program needs a lot of correctness, you can have a directive called spec, where it becomes much stronger, and then you can use a tool called dialyzer, which is in addition to its for static analysis. Right? It doesn't come as part of the compiler; it's a separate tool, and you can make it a part of your build pipeline. It's quite easy, so you can become strongly typed if you wish to, but the choice is up to you, right? Another interesting feature of the Erlang VM or OTP is location transparency, right? So we just talked about what a process is in Erlang/Elixir, right? It's like a virtual process inside your OS process. The thing is, now this can be called, let's say you have machines in a cluster, and if you configure your cluster in a way, any process can be called from any machine or any other OS process transparently without knowing that they are on a different machine. Right, and that's a very powerful thing, right? So let's say you have some processes which are really resource heavy, you can provision them separately in a separate machine or something, but you can call them from any client code as you would call like local code, right? So it kind of gives you the best of both worlds of having like a monolithic code base or probably also distributing your deployments, right? So let's just see how this works. Let's do a quick demo of how this can work, all right? So to do that, let's first change our counter to to something different a little bit, right? So let's give this a name when it starts, right? So you can say name colon. This is called a keyword list data structure. You can say name colon. You have to say global. Unfortunately, I haven't found a way around it. Let's call it Count Dracula, right? So now when you start a process, it'll be started with this, and if you try to restart this process, it's going to say no. Let's use this thing called IEX, right? So this basically gives you like an interactive way of doing things, and you can say counter.init of 10, right? And gives you a PID. If you see this, gives you process ID, right? If I try to do the same thing again, no, it says already started because I've kind of bound it to the global name called Count Dracula. It cannot start again. Obviously, you can parameterize it and have multiple processes, but let's not do that for the sake of the demo, right? So now this is already started, so I can't start this process. So let's get out of it. So what you could also do is to actually have these global, like a cluster of machines. You have to start. You have to give your node a name. So Elixir has this concept of nodes which talk to each other. So you have to give it a name, right? And it's usually your machine name, or you can say something like server at your machine name, right? S name stands for start name. So my machine name is Uttam's MacBook Pro, right? And there you go. Oops. Might have forgotten the command. So let me look at my history. Yeah. Yeah. You're in, right? Let's start another thing, same way here. So instead of saying server, let's call it client. So I've got two. What? Sorry, wrong folder. All right, so I've got a server and a client, right? So let's actually, initialize the counter on the server side. Counter.init, let's say 4. All right, as a PID, done, right? I can call this function as counter dot value, right? You have to pass a PID. Instead of the PID, you can also pass global comma count Dracula. Right? And and it gives you the value. All right. So this is on the server side, so it's there, right? So let's try to connect it. So you can say node.list and see which nodes are connected. It's empty. You can say node.connect, right? And you have to give this. All right. It's a atom, so you have to give that colon in the beginning. Atoms can have special characters and spaces as well. And it's connected. So now if I say node.list, server turns up in the list of nodes on the client, right? And if I do a node.list here, client's there. So they know each other. So you just have to do it from one end. You don't have to initiate this connection, right? Now I can do the same thing that I did here over here because it's a global name. Gives me the same value that is there on the server, right? And I can increment it as well. I can say increment, right? And the second type 2, it gives me 6. And if I say counter.value here, it gives me 6. So as you can see, I'm in 2 different processes. This could be 2 different machines, but I can use the same interface to pass messages between this, and this is really powerful. Again, on a daily basis, you wouldn't want to do this. It's too low level, what we just did. A lot of frameworks and libraries will leverage this for you, right? So this is what location transparency is. There's no HTTP server, there's nothing, it's all taken care of by the platform for you, all right? Cool. Let's move on. Again, this is the OTP thing, right? So let's say you have a process and something bad happens. You pass a string where it's expecting a number and there's an exception. It's a dynamic language, right? And this process by default will crash, right? And you wouldn't want this to be dead forever because you would want it to serve new requests. So the OTP platform has a concept of supervisors. Supervisors are other processes which kind of monitor other processes which monitor processes, like a hierarchy. So you can configure a supervisor to say if a process crashes, just restart one process or restart all processes because there's a dependency somewhere. So you could configure it anyway, right? And you can probably log it or whatever and then restart it, right? And the good part is it will restore your known state before the crash happens. So you're not going to lose your state if your server had state, right? So this is called the let it crash philosophy of Erlang. This is for telecom systems where there will be real-time crashes, but you should not have the whole system crash, right? So today if you write a main program in Java and there's an exception, the program crashes. It can't do anything more, right? But in this case, since processes are like within like a sandbox within the existing Erlang VM, if one process crashes, it doesn't change the entire system. So you have very localized error handling here, right? So that's what supervisors are for. And Mix has this concept of applications where when you say load a module, you can say start this process. For example, here we said counter.init, right? You could do that by default. When you load the library called counter, it creates a server called count Dracula for you, and you don't have to do it yourself. And let's say there's an error, it will restart that count Dracula for you, right? So that's what supervisors and applications are. All right. Whew. Cool. So let's get to some real world stuff now. Right? I mean, we did a lot of algorithmic or programming thing. So one of the things which a lot of us do is write web apps, right? I mean, we do a lot of business programming, right? And it requires HTTP servers, whether they are regular websites or whether they are APIs. We do this a lot, right? We talk to a database, we read stuff, change data from one format, display it somewhere, right? So Elixir has a great framework called Phoenix. It's again inspired by Ruby on Rails, right? A lot of Rails developers will find it very familiar, find the concepts very familiar, right? And it's focused on dev productivity, right? It's just focused on getting you started quickly, right? It's got a list of defaults, which can be changed, but it's harder to change those. That's again the Rails trade-off you make usually. And it's fast, right? I mean, it can handle millions of connections because each request is a virtual process inside the Erlang VM, and it's all asynchronous, right? So it has microsecond response times usually, and it tells you, it took me 20 microseconds or 100 microseconds because most web apps these days, like Rails or even Django, they are in the order of hundreds of milliseconds, if not less. right? Not more. So this is really performant, and support for WebSockets is amazing. I mean, it gives you all things set up for you. So let's just write a small app and see how how this can work for you, right? So I'm going to kill this. Let's go back and let's create a new Phoenix server. Right? So let's create a simple API which returns a list of users. Let's call it Phoenix.new, right? So you can say user API. Mix also acts like your npm/maven Gradle. It installs dependencies for you. So there's a lot of libraries. So what it's doing is it's now doing also an npm install. It assumes that you have a web app. So like I said, it's like Rails. It sets up everything for you. You have to opt out when you start out. Hey, I don't want npm. I don't want this. Right. So it's like all opt-in, and you just start working. Right. So the reason this is slow is not because of mix. It's because of npm, and we all know how slow npm can be. Right. So. And it's compiling them as well. All right, this is the user-friendly part of it, right? Now, I just did this, now it tells me what I need to do next, right? It tells me cd user API, okay? Ecto is the ORM, it's like active record for Rails, so you can just create your database right now. I'll just drop my DB if it was there. Okay, does not exist, that's cool. So I'll just create this database using the command that they give me, perfect. Okay, so it says Postgres does not exist, so which means I need to change my my DB connection string here. It's not called Postgres on my machine, it's called from without any password. All right, so let's run this again. And if you see, it's generated the database for me. Awesome. Now let's run the server, right? And you have a server running, as simple as that. So let's get out of this. Let's do localhost 4000. There you go. So you just have a server spun up. These are the commands, right? It's quick. So let's add our API now, right? So let's go to cd/user API. So it has a command called gen fix.gen JSON, right? So you can create like a context called accounts, which has a model called user. The API path is users, and if you want to write a simple CRUD API, right? Obviously, you would want to change that, but it's good to get started. And you just do this, and it's created it for you, right? And it also says you have to run migrations now. It tells you what to do next, right? So what this does is this will create the tables in the DB for me. Oops. This is broken for whatever reason. Something has to give in a demo, right? This is it. I've seen this happen before when I'm probably running a server. It just... Okay. Let's do it again. I'll remove this. I'll run this really quickly. So, sorry if he's, new, right? It's going to take time. Shouldn't have done that. I think it has to compile everything because the package manager doesn't give you compiled Beam files. It gives you only the source code. So maybe it takes time, right? So we've already created the DB, so that's fine. So we don't have to do this. So let's do the new user API. We'll generate this again. Could not be found. Sorry. User API. Yeah, it also tells you to add this. I think I forgot about this. Right? So you have to add this in your router. Um, and you also have to change the dev.exs back here. All right. Okay, let's keep our fingers crossed. Also have to run mix ecto migrate. This will run your migrations for you. Yeah, it worked this time. Maybe it's a little buggy somewhere, which I don't know where. All right, so now let's run our servers, right? Mix phoenix.server. Perfect. We created the endpoint, and let's go to 4000 and just say users. It's empty now. There's no data in the DB. So let's create some data in the DB, right? Manually. What? This also happens sometimes. PSQL. That's fine. So this is PostgreSQL for people who don't know. It's got cryptic commands. Just getting my hang. I haven't used it a lot. So you can connect to DB with C. So I'll call it user API dev. That's what it's generated over here, I think. Yeah, that's the DB name. So this is connected. So let's say select. That's the name you use. Star from users. It's empty. Let's insert something into users. Alright, values. So if you see, it's generated these fields for you. So you just said first name and last name, but it's generated the inserted at, updated at by default, and obviously the auto-generated ID, right? So kind of like Rails, if you're familiar. So let's do this and this. Remember to use single quotes in Postgres. Doesn't work otherwise. Now, right? And if I do select star from users, there it is. Cool. So now let's hit our API. Perfect. Right? So now you have it. Let's take a look at the code it's generated. It's not exactly magic. It's actually generated code, and you can change it. Right? So when you create an API, it gives you like an index which tells list users, and then goes to, you have create. So this is the ORM call, I think, which happens, and everything else you got delete and you got update. So they're like put and delete calls in HTTP, I guess. So I'm sure there'll be options where you can just have a few when you run the command. Not quite familiar. So this is generated now. You can just change this whichever way you want. Right? You can write your tests. You can write your abstractions from here, but it makes it really easy for you to write this. Right? So I think let's go to the user.ex, which is like your model class. So this is the Ecto framework, right? So you have a schema. It tells you what fields you have. Cool. So this was Phoenix. So it's really easy to get started. So you can just start. You don't have to even know what a gen server is or it's anything. You can, if you know basic syntax of Elixir, you can just write a web app yourself without all this. Awesome. So let's go to the last slide. Reach the end. So I think this is a little more philosophical. I think you have to be patient when you learn something new. Like I was really impatient when I started with Haskell or Clojure, but I've gotten better with it. I've stuck to it. If I get really bored, I kind of leave it for a couple of days and come back. So I think patience is important, and that's a part of learning. If you don't do it, you'll be kind of stuck where you are. Learning a new language makes you better programmer even in your current language, right? So programmer, not program. Right? So just last week, just a couple of days ago, I think we had a production issue where I work at a customer place, right? And this was a code base we hadn't written. It was written using Java, but it uses Akka actors, right? And we had like this kind of one actor waiting for the other kind of scenario. And I think me understanding Elixir and the OTP made me understand the bug and resolve it without understanding how Akka exactly works, right? So they're similar, right? Actor framework and this is similar. So sometimes you may think, you know what, it may not work for me, but there will be cases in your life where knowing different ways of doing things will help you in your current workplace. So it's important to, broaden your horizon in terms of learning different languages, right? And also, I think you don't have to learn everything at once, right? I mean, if you see these slides were about functional programming, but I didn't use any functional programming, the dreaded M words of functional programming at all. Even though I understand them a little bit, I'm still a novice, but it's important to just get going sometimes. And everybody has a different way of learning. Some people are like math nerds, then maybe start with Haskell, right? It's for you because you relate to it better. I'm not a math nerd. For me, I like to build things, right? So for me, Elixir worked really well because I could build something in Ector this quickly, right? With Phoenix and Ector, right? It's amazing, right? So I think every person has their own way of learning, but try different things. I used to be a book reader at one point, but I've changed. I watch interactive videos and tutorials instead of books, right? Because books have become boring for me now, but they were good at a certain point. So do whatever it takes, but again, be patient, right? I mean, don't give up. And I think most importantly, enjoy what you're doing, what you're learning. And I think that reduces the chances of dropping out, right? I mean, if you're bored with what you're doing, then you just drop out. But if you enjoy what you're doing, whichever way it is, you will not drop out. So that's it. Cool. Thank you. Any questions?
Does this language have a concept of like lazy sequences?
I'm sure it does. It does, yes. It's a functional programming language, so build, but yeah.
How long have you spent with Elixir?
2 months. Yeah, so I have not done this in production, by the way. I mean, I've never used it at a customer. I've just do it. It's a hobbyist kind of thing, right? So maybe I'll get a chance someday.
Any companies using it right now?
Oh yeah, so I'll give Elixir, yes, but Erlang has been around for a long time. So for example, WhatsApp uses Erlang for their core servers, right? And they just had 35 engineers when they had 450 million users, and that was their team. And Facebook bought them for $19 billion. And one of their successes they attribute to is Erlang and the OTP way of doing things, and that's how that was a competitive advantage for them. And you'll find lots of Pinterest uses them, lots of companies are using them. So Elixir has been used, so it's out there. You can find literature a lot, right?
Elixir is like a compiler, but it's also compared to Erlang.
Beam, yes.
Yeah. So now when the runtime error happens, one of the things is the runtime error happens.
Yes.
How easy to debug the code? Like when our source code will match that. If it comparison error, we will know that. But like runtime error, how easy to debug?
Again, I have not done this because I've not used this in production, but I've read about it where you can actually go and debug a running application without stopping it in production. So
my only doubt is, since it's compiled now, will it have something similar to source maps or something like that?
I'm sure it will. It will. It does, yes. And you've got IEX. I just showed you IEX, right? It's interactive. So we can probably connect to a running instance and do pass messages and do things to that. Any other questions?
So is it applied to these kind of like these model?
Could be. Again, I'm also new to this. I'm sure there will be. Yes.
Phoenix is like a framework. It's not associated with this thing. Yeah, there is a similar to this microservices available.
Yeah. There will be. I'm sure. It's a big ecosystem out there.
So I can use the Erlang libraries, right?
Yes, you can use Erlang libraries.
That is something of plumbing, I think, at least some plumbing basic concept in the
Yep. Cool. Thanks, guys. Thanks for your patience.